Well, now let's look at some special cases of combinations that hopefully you'll memorize. You won't have to plug these into the formula every single time. For example, C6, 6. So what does that mean? It's the combination of 6 things taken 6 at a time. So you're taking all of them. Another way of saying that is what? I like to say 6, choose 6. How many ways are there to choose 6 things out of a group of 6? You can't leave any behind, so you have to take them all. There is only one way to do it. So 6 choose 6, just like 7 choose 7 or 10 choose 10. There's only one way to do it. And let's prove it by plugging it into the formula. 6 goes on top, 6 factorial, and then what's 6 minus 6? That's 0 factorial, which don't forget, that's equal to 1 times 6 factorial. This top 6 factorial is because of this 6. This 6 factorial is because of the second one. And that's the 6 factorial over 6 factorial cancels out to 1, and 0 factorial on the bottom is just 1. So that's 1. Let's move straight down to the general case. N can be any number from 0, 1, 2, 3, to a billion, a trillion. It does not matter. What do you think CNN is going to be? How many ways can you choose n things from a group of n? Only one way. And in this case, it would be n factorial over 0 factorial, n factorial, and we get a 1. So those you don't need to plug into the formula. Just remember it. If you got one more example, if you got 15 people in a room and you need and somebody comes in and says, "Hey, I need 15 people. How many ways can I choose 15 out of you group of 15?" Only one way. I've got to take all of you. All right. Now this one's a little weird. How many ways can I, out of a group of 6 people, how many ways can I choose 0? 6. Choose 0. Well, it's going to be 1. Just remember that. If you're not choosing anybody, if you're choosing 0, it means you have to leave everybody there. So there's one way to do it. And this would be 6 factorial over 6 minus 0 is 6 factorial, and then 0 factorial. Well, notice that's exactly the same thing as this one. And why is that? Because 0 plus 6 add up to the first number, which is 6. We've talked about that already. So in general, n people, n choose 0. The combination of n things taken 0 at a time, so you're choosing 0, is going to be a 1. Well, I guess I didn't write that up there. All right. Well, without plugging it into the formula, let me ask you this. If you have 6 people in a room, how many ways can I choose? 1. Well, there are 6 people to choose from, and if you're choosing 1, it makes sense that you'd be choosing 6. You have 6 possibilities. 6 factorial on top. 6 minus 1 is 5 factorial times 1 factorial. Well, the 1 factorial is just a 1. 6 factorial over 5 factorial, I think we've looked at that in a previous video. That's 6. And in general, you got n people in a room. How many ways could you choose one of them? There are n different people, so there are n ways to choose that one person. Okay, so in this next example, we're going to warm up a little bit, but it's going to combine some stuff that we've done in previous videos, actually previous sections. So recall the multiplication rule, where you have a bunch of tasks, task 1, task 2, and so on. This we'll just review it for 2 tasks. If there are n different ways to do task 1, and there are m different ways to do task 2, then there are blank ways to do task 1 followed by task 2. Remember that? There are n ways to do the first one, and there are m ways to do the second one. That would be like saying if I have n shirts and m pairs of pants, how many different outfits could I make? Well, n times m. And if you had 3 tasks I mean, you just multiply them all together. You know, you could have 10 tasks, and you take all the number of ways to do all the tasks, and you multiply them all together. All right, so here's our warm-up question. If a cafeteria offers 4 meats, 6 veggies, 5 desserts, in how many ways can you choose a meal if it consists of one of each of those? 1 meat, 1 vegetable, 5 desserts. Well, you could think of that as task 1. How many ways can you choose 1 meat out of a group of 4? 4. Times what? How many ways can you choose 1 vegetable when there are 6 vegetables to choose from? 6. How many ways can you choose 1 dessert when there are 5 desserts to choose from? That's it. That's the answer. Now, what does that equal to? 30 times 4, 120. Really what we did is we said, well, to get the number 4, how many ways can you choose 1 item out of 4? What is 4 choose 1? It's equal to 4 times combination of 6 choosing 1 times the combination of 5 choosing 1. That's really what we did, but it's so easy. We don't bother using the combination formula because, like we said up here, the combination of n, it doesn't matter what n is, the combination of n things taken one at a time, where it's like n choose 1. There are n ways to do it because there are n different things to choose from, and you're choosing 1. All right, I stated that for a reason. Here we go. It'd be nice, maybe you should pause the video and see if you can come up with this one yourself. All right, the cafeteria offers 4 meats, 6 vegetables, 5 desserts. Notice that's exactly the same as the previous problem. In how many ways can you choose a meal of 2 different meats, 3 different vegetables, and 1 dessert? Well, it's really not that difficult if you look at the way we wrote the answer here to the previous problem. Well, how many ways can you choose 2 different meats? How many meats are there? 4. Well, before we said the combination of 4 meats choosing 1 of them, this is going to be that. That's how many ways we can choose the meats. Times, how many ways can we choose the vegetables? Well, we have to choose 3 of them, so it's the combination of 6 vegetables taken 3 at a time. 6, choose 3. 6 vegetables, choose 3 of them. Times combination, 5 desserts, choose 1 of them. That's the exact answer. Now, I'm going to require that you simplify this, so maybe I'll do that real quickly. 4 choose 2, I remember that's 6. It's 4 factorial over 2 factorial, 2 factorial. The first 2 came from the 4 minus 2, and then that 2 is the second one. Times 6 factorial over 3 factorial, 3 factorial. 6 minus 3 is 3, and then that 3 gets copied down there. Times 5 choose 1. I'm not even going to write it down. We know that 5 choose 1 is 5. Well, this is, you can work this out. This is 4, 3, 2 over 2 times 2. Because 2 factorial is just 2. Okay, 6 factorial over 3 factorial, 3 factorial is the same as 6, 5, 4. And I'm going to cancel the 3, 2, 1 with one of the 3 factorials. One of the 3 factorials just went away. It canceled with the 3, 2, 1 on top. Now 3 factorial is just 6. So that's the second term. And the third term is just number 5. So, do we have it yet? We've got this middle term is 20, 5 times 4. And then we have 6 times 5 is 30. 30 times 20 is 600. So when you allow more freedoms, allow people to choose more than one thing, 2 different meats, 3 different vegetables, well, only one dessert, it really increases the number of possibilities. So you could say in this scenario, there are 600 different meals that you can make with just this 4 meats, 6 vegetables, 5 desserts, where you're selecting 2, 3, and 1, respectively.